Hello everyone. First of all, thank you for coming to my presentation. My name is Marko Lohert, and I will tell you a little bit about the future of WebAssembly. It's not a small story, it's a long story, but we will cover what we can cover in the next half an hour. WebAssembly is not actually a new technology, but it's gaining a momentum in the last few years. So let's see what can we learn about the future of this technology. My plan for this presentation is to talk about actually two things. One is, let's talk about new features that are coming to WebAssembly. WebAssembly became a standard, WebAssembly 1.0, in the December of 2017. In 2017 we got a standard, and that was MVP, minimum viable product. We got some new features after that, and some new additional features are coming. We will see some of them today. And another thing that I want to talk about today are the new places where WebAssembly will be used. I'm calling that new places, and we will see what I mean when I come to the second part of this presentation. When talking about the future of WebAssembly, my plan is to start with the current state of WebAssembly and go step by step further and further to the future. We'll go first into, let's call them shallow waters, the things that may come this year or next year, and then we will come to horizon, the features and the possibilities that will arrive later on. So, when talking about the current state of WebAssembly, here we can see that currently in our browsers we have two technologies. One is JavaScript. That's the main technology. That's, I would say, the default technology. That's the one that is used most. And there is a new player, WebAssembly. That's bytecode that can be run inside the browser. It has its benefits. It's faster than JavaScript. It's smaller. And it has some interesting features. For example, you can take some other language, C, C++, Rust, take a code in that language and compile it to WebAssembly. In that way, WebAssembly is actually a compilation target for those languages. We can compile to WebAssembly. We do not need to write actually in WebAssembly itself. WebAssembly code in WebAssembly runs in a sandbox like JavaScript, so it brings security. I don't know how many of you have previously worked with WebAssembly, heard something about WebAssembly. I see some people are one hand here. Okay, great. Some people have worked with it. I will not go into details because I would like to see what's next. What would we like to have in WebAssembly? What are our goals? More languages, C, C++, Rust. These are not the most popular languages at this point, and there are other candidates. By the way, from these three languages, Rust is mostly used for WebAssembly. There are some nice examples with C++, but Rust is mostly used. These languages have something in common, and that thing will be important 2 slides from now. But for now, let's see what else we want to have in WebAssembly. We want to have more features. Currently, WebAssembly version 1.0 is MVP, minimum viable product. Some things are missing. From December 2017, some things have been added, like support for threads. That was relatively recently added to WebAssembly. Also, our goal is to move WebAssembly outside the browser. It was first created in the browser, but people have looked at the WebAssembly and find that WebAssembly itself, the code itself, does not need browser. It communicates with browser via APIs. If we had some other APIs, WebAssembly could live outside the browser. So let's start with the new features that are coming to WebAssembly. First feature, garbage collection. I said 2 slides ago that C, C++, and Rust have something in common. These languages do not use garbage collection, so they can be easily compiled to WebAssembly. But many languages, Java for example, use garbage collection. So WebAssembly does not have a garbage collection yet. What are the alternatives? We could move a runtime itself, Java runtime or Boom or any other runtime from C++ to WebAssembly, and then run a runtime in a browser and run the language on top of the runtime. Okay, that's a little bit complicated, and the fact that we are losing performance here is actually not nice, because WebAssembly has come with the promise of great performance. Currently, browsers are working on a support for garbage collection. That means that some browsers have gone further, some not so further. I have read somewhere that Chrome has moved the furthest in this regard. And programming languages are moving also with support for garbage collection. So these languages, Java, Kotlin, Dart, are working on the support for garbage collection inside WebAssembly. Tail call optimization is quite common in some languages, and these languages rely a lot of tail call optimizations. But this is also another thing that is currently not in WebAssembly, and the work is being done to move it to WebAssembly. The other thing is memory. Memory 64 means that we can use more than 4 gigabytes of RAM inside the WebAssembly. Currently, we can use only 4 gigabytes, but soon we will be able to move beyond 4 gigabytes. This example is actually a nice example where we can see that some browsers have moved further, some not so. Some browsers will support memory 64 by using a feature flag. You need to start it with an appropriate feature flag, or it can be used in nightly builds. I will not go through all the new features, but I will cover one more. That's single instruction, multiple data. Our CPUs currently support the feature to have single instruction that is in parallel working on a number of data, 4 or 8 pieces of data, depending, are we talking about integers or double. Some work has been done, the basic work for supporting of single instruction, multiple data in WebAssembly, but there are some new things that must be done. So what is the goal? The goal is to have a better performance. And that's actually a really good thing to see here, that WebAssembly is trying to maintain the great performance. If you want to see the other features, you can take a look at the roadmap. Roadmap goes by browser, and we can see which browser supports which feature. Also, there are proposals. More proposals are coming. The thing is, WebAssembly is supported currently in all browsers, desktop and mobile. And to get support in so many different browsers, we need to have some kind of process, cooperation between those organizations and those folks. And that means we have phases from phase 0, that's initial phase, all the way up to phase 5. Phase 3 and 4 are actually really good phases, because things are pretty much done in those phases. Okay, in the next part, I would like to talk about WebAssembly outside the browser. So currently WebAssembly is running inside the browser, but people have seen that there is a great potential to run it outside the browser. So WebAssembly itself does not depend on the browser. It communicates with the browser via APIs. If we would have another set of APIs, we could communicate with operating system instead of the browser. So we have a number of runtimes. A number of people are working on getting this thing done. The first one, WebAssembly. That's the most popular. As far as I see, that's the most popular at this point. The organization behind WebAssembly is Bytecode Alliance. We will see that name on a few more slides. We have different WebAssembly runtimes. WebAssembly is actually interpreter. All others are JIT or AOT, ahead of time compilation. So the idea is, let's move WebAssembly to server. Why not IoT? Why not Edge? There are some ideas to move it all the way to IoT. I said that we need a set of APIs for WebAssembly to communicate with the host, with the operating system outside the browser. One initiative is WebAssembly system interface. The goal is for this to become the standard for WebAssembly outside of the browser. It's built by WebAssembly, and that's the same WebAssembly from the previous slide. Well, perhaps you have already heard something about WebAssembly system interface. There were talks about it for a few years now, but the current state is prototype. So we currently have a prototype for this, but not more. It's really nice that things are open and transparent, and people are talking about the progress in this area. So if we take the picture from the beginning of this talk and add WebAssembly system interface, we will add it down here at the bottom, where you can communicate with WebAssembly. So we have languages like C, C++, Rust, and many more that are coming. They are compiled to WebAssembly. The compilation target is WebAssembly, and it communicates with APIs that are WebAssembly system interface. These APIs allow me to communicate with any host, any operating system. So WebAssembly can run on any operating system. That's the idea behind WebAssembly system interface. Any operating system, any platform. So x86, ARM, I read something about RISC-V. RISC-V also being the one of platforms that will be the target for WebAssembly in the end. Okay, if we are talking about WebAssembly outside of the browser, why not containers? Why wouldn't we put them in containers and run them as any other Linux Docker image? They can be run. The difference is that the WebAssembly containers with WebAssembly will be faster. We're talking about less than a second to start, and a smaller. We're talking about perhaps megabytes, tens of megabytes. The question is, does it mean that WebAssembly will dominate containers and all the images will be WebAssembly? I would say no. They will coexist with the current standard Linux Docker images. They will live side by side. I'm not the only one who thinks so. Let's not get into hype and believe that there will be all WebAssembly. It will be coexisting with the current ecosystem. Docker plus WASM is a product by Docker itself. It's currently in beta. There is a link, you can Google it or take a picture of this link. In this link you can see that this is something that is been working on. There are instructions how you can test this. This link, or I believe we need to click on getting started or some other button and get to instructions for testing this Docker plus Wasm. This is beta. And one other thing, Docker is a voting member of Bytecode Alliance. That's the same Bytecode Alliance that is behind WebAssembly system interface and behind Wasm time runtime. So that's the name that you will hear a lot when talking about WebAssembly. Okay, so these are the ideas, these are the informations. What would I like to know is, okay, what's in real life, in practice? Is it really used this much or is it not used? So I have digged out a couple of surveys. It's from the last year. I didn't dig up something from this year, but okay, this will be good enough for us. Because here we can see that Rust is the most frequently used language at this point. And not only most frequently used, but the language that that is mostly loved in WebAssembly community at this point. Of course, let's remember, garbage collection is something that is coming to WebAssembly. When a garbage collection comes to WebAssembly, that will open a window for many new languages. Some of those languages are already preparing to come to the WebAssembly ecosystem, Java, Dart, Kotlin, for example, and that can affect these results. Also, we see the rise of usage of WebAssembly in serverless and containerization. One thing that people have said in this survey is that basically WebAssembly needs more support outside of the browser. They like the idea, but currently they believe that more work should be done. Here we have a link. There is a number of charts on that web page. I will take only two of those. Desired language. Rust, it's mostly used, but it's also the most loved language, or how it's put here, the one that people want to use a lot. C++, it's one of the standard languages for Rust, but according to this survey, it's not so much loved. You have maybe heard of a nice example of usage of WebAssembly. AutoCAD has used a really old code base and moved it to, that's C++ code base, and moved it to WebAssembly. That was one of the first examples that were really used in presentations about WebAssembly. So maybe you can find your favorite language here. Maybe you like what you see about your favorite language. Maybe you have a different opinion about it. We can talk about it when we come to Q&A. Actually, I would be quite interested to hear, did somebody used any of these languages with WebAssembly? Okay. That's great. During the Q&A, feel free to share your experiences and we can start the discussion. Runtimes. We had a few slides ago a list of runtimes, and we can see here that Wasm time is the most loved, most used of these. And it's one of those runtimes. Personally, I feel that it's too early to say which of these will win. It will take time. Another survey from the last year also talks about WebAssembly and why do people like it. The fact that people can choose their own language that will be used in a browser, so we do not depend on JavaScript, only on JavaScript anymore. And the performance, the high-speed performance. WebAssembly ecosystem talks about near runtime performance, and that's actually quite great. From this survey, I will pick up this result. Now, it may seem a lot to say that a third of people are already using WebAssembly, but you have to take into consideration that it doesn't mean that all developers have answered this survey. Probably the ones who are working with WebAssembly have answered. But what actually is interesting for me to see here that those who are not using WebAssembly, many of those are actually planning to use it in the next half a year or next year. Well, let's talk about a few things that I would like you to remember from this talk. So, WebAssembly is getting new features. Currently, it's officially version 1.0, but many new features have been added. In my opinion, the one that will influence WebAssembly ecosystem is the one that is garbage collection. That will influence mostly the ecosystem because it will bring many new languages to WebAssembly. WebAssembly will become a compilation target for many languages. People are talking about write once, run anyway, or anywhere. It's not a new idea actually, but it's quite common to hear that in WebAssembly world. When talking about WebAssembly, or WASM for short, outside of the browser, please take a note of WebAssembly system interface and these APIs. The idea behind them is that they will allow us to run WebAssembly code on any operating system, on any platform, x86, ARM, whatever. And WebAssembly in containers are coming. Docker plus WASM is project by Docker that is in beta. And in my opinion, and not only in my opinion, this will run together with traditional Linux Docker containers. So we have a Q&A. If somebody wants to share experience about WebAssembly, that would be great. Thank you.
So I've actually used WebAssembly, yes, 2 days ago, and
excellent.
I've been learning Rust for a while now, and I really like the language, but needed a more practical way to use it, and I think WebAssembly is what will bring that to me. I've used it vanilla, and I've actually tried to make it work with React.js. I've started a new project and made a WASM library using Rust. And I haven't actually made anything with it, but I think it'll be a nice experience.
I think this is great. Applause would be nice. This is great. I'm really glad to hear that people are using it. Also, I'm glad to hear that you have some special project that you're working on. Here, I have not copied all the things from this survey, but here at this survey you can find that what types of projects are people working on. Some of them are games, Some of them are, let's say, more serious software. Some of them are already IoT. So thank you for sharing. I think it was great. And thank you also for sharing feedback about the Rust language.
You're welcome.
I think we have a minute or two. If we have one more question.
Thank you. I'm not a WebAssembly user, but I'm really a huge fan of it because it actually tries to conquer the JavaScript and its bloatness. And I'm asking for your opinion. Do we see in the near future that happening?
Sorry, didn't get the full question. Do I see in the near future?
In the future that the WebAssembly will be the main product that will run all our internet instead of the standard JavaScript.
That's actually could be a whole discussion, but in my opinion, WebAssembly will not in the near future replace JavaScript, because JavaScript is currently too strong.
Yes, but the WebAssembly was born actually on the completely opposite reason.
Yeah, but if we are talking about the usage, it takes time for people to come from one language to another. I see many benefits of WebAssembly. In the more further future, who knows, maybe WebAssembly will be more important than JavaScript. But if we are talking about the current state and the near future, JavaScript has a lot of code that already exists. And that's the thing. I think that's probably the more important thing than the language itself, because so many libraries are already out there and people will use those libraries. By the way, there is a way we can use JavaScript from WebAssembly, and I believe that in the near future that will be used a lot. Okay.
Thank you.
Thank you. And I think that we are out of the time. I will leave a few minutes for my colleague to continue after me, and that means that it has come time for me to say thank you. Thank you for coming to my presentation.